Hello and welcome back to another video. In this problem, we have the expression 4x squared plus 6x over 4x plus 2. And we're asked which of the following is equivalent to that. So if you could, the first thing you would try and do is to try and get a common factor out of these. And maybe you could pull out a 2 from all of them, but that's not actually going to really help anything. So the way we're going to solve this is using long division, polynomial long division. So we're taking 4x squared plus 6x, and then add plus 0, right? We have to add all of our terms in decreasing order of the number of x's. So our constant is 0, but we still have to write it just so that the long division works. And then we have 4x plus 2. So this works sort of similar to normal long division. We say, okay, 4x is our leading term, so the leading term here is 4x squared. What do I have to multiply 4x by to get 4x squared? Well, 4x times x is 4x squared. So then we multiply 4x plus 2 times x. So we get 4x squared plus 2 times x is plus 2x. And now you subtract. Again, this is very similar to normal long division. These cancel, which was the goal. And then 6x minus 2x is 4x. And then we drop down the plus 0. That's why we had to have it. You can't skip terms. So 4x, how many times does it go into 4x? Well, it's the same thing, it's itself, so it goes in one time. So then we have to multiply this by 1. We get 4x times 1 is 1, or is 4x. 2 times 1 is going to be plus 2. And again, we subtract. These cancel out. 0 minus 2 is negative 2. How many times does 4x go into negative 2? Well, it doesn't. It has an x term. It doesn't go into a constant. So we've reached the remainder. So the remainder, what does that mean for this case? Well, it's minus 2 over the divisor. So our final solution is this up here. So we have x plus 1 minus 2 over 4x plus 2. So you can think of this as it goes in x plus 1 times with a remainder of 2. And this is equivalent to D, which is going to be your final answer. As always, thank you for liking and subscribing, and I'll see you in the next video.